Okay, so 76 starts off, it says a particle starting at rest at time 0 moves along a line so that its acceleration is given by 12t. So I'll put that part of the problem in. How much distance has the particle covered during the first 3 seconds? Okay, so this is also the section of the this is also the section which you're able to use a graphing calculator, I believe. Let me just double check. Well, it doesn't appear to have said that, but anyways, usually this far into an exam it is. But well, we don't need it, so I guess I won't. I guess I won't wimp out and grab a calculator. So if I want to know how much distance, or do you guys remember what the? If we think about how much distance, you remember what the trick was when we were talking about distance? Like technically every day when I go to work and then I go home, I've done 0 kilometers. Yeah, it's absolute value is what we're talking about, right? So it's the absolute value of the change in position. So we have a few things that we need to work out here. We should always remember that relationship, right? That'll go from acceleration, velocity, and I guess I'll call this one P for position then. So one thing I forgot there is if you wanted to get the distance, you'd add up all the change in positions, right? So if I keep telling you how the position has changed and you keep adding it to a running total, then you know you're going to end up with the total distance at the end of that. Okay, so if we have 12t for the acceleration, what would the velocity be? Yeah, we're going to have to integrate. We're going to have to integrate the velocity, or sorry, the acceleration. So for us, that's going to be the integral of 12t dt. So I'm going to get 6t squared and a constant. So the way we find the constant is it tells us that it is at rest when time is 0. That basically means that the velocity at 0 equals 0. So we can substitute in and the constant is a 0. Okay, so now I know what my velocity function is. It's going to be 6t squared. And remember, we just mentioned that if you want to get the distance, you have to add up all of the changes in position. And change in position is velocity, right? So we're going to find the integral of 6t squared dt from 0 to 3. And yes, we are looking for the absolute value, but how come I can do this? Yeah, it's squared. There'll always be positive values in here, so we don't need to worry about it. If we did have a problem, how would you deal with it if there were absolute value brackets in there? Yeah, it starts with a P.
Split it in half.
Yeah, split it in pieces, right? Piecewise graph is the way you deal with it. You can remove the absolute value when you split it into pieces. So fortunately, we don't have to go to that effort here. So this is going to be from 0 to 3 of 6t squared. For us, that's going to be, let's see here, 2t cubed evaluated from 0 to 3. And that'll be 2 times 3 cubed minus 2 times 0 cubed. So 2 times 27. So 54. The total distance it's covered should be 54, which is D.